Hello everyone, in this video we will discuss about the GATE 2011 questions in the subject networks. The first question is a layer 4 firewall, a device that can look at all protocol headers up to the transport layer cannot. These are the options. In option D, block TCP traffic. Option C, stop incoming traffic from a specific IP address. And in option B, block all ICMP traffic. In D, TCP is a transport layer protocol, and both of these are regarding network layer. But in option A, HTTP is an application layer protocol. So layer 4 firewall means it can deal up to transport layer only. So all these can be done by this layer 4 firewall, but option A cannot be done as it is an application layer protocol. The next question, consider different activities related to email. M1, send an email from a mail client to mail server. M2, download an email from mailbox. M3, checking email in a web browser. What is the applicable level protocol user in each activity? So for sending an email from mail client to mail server, we need SMTP, and for downloading we need POP, and application layer protocol is HTTP. And one more protocol at the transport layer is also required for the email service, which is TCP. So the option C will be the right answer, as M1 SMTP, M2 POP and M3 HTTP. SMTP means it is simple mail transfer protocol. POP means it is post office protocol. One for the sender side and one at the receiver side. The next question, the network uses a distance vector routing protocol. Once the routers have stabilized the distance vectors at different nodes are as following. So these are the shortest distance from N1 to every other node, from N2 to every other node. This is the distance vector table. And what is distance vector algorithm is explained here. A distance vector means is distance of the best known path at that instance to nodes N1 to N5, where the distance to itself is 0. Also, all links are symmetric and the cost is identical in both directions. In each round, all nodes exchange their distance vectors with their respective neighbors. Then all nodes update their distance vectors. In between two rounds, any change in cost of a link will cause the two incident nodes to change only that entry in their distance vectors. That means distance vector means it's the best path or shortest distance from each node to every other node, and the cost is identical in both direction. Suppose if any of the node changes its distance values, and all the before that these tables will be shared by each node to the immediate neighbors. Suppose N2 has a table, and N2 will share that table to its neighbors. Who are that? It is N1, N5 and N3. Suppose N2 changes something, that will be reflected to N3's table, N1's table and N5's table. Okay, that will be propagated to the every other nodes. This is what is a distance vector routing algorithm. Here the cost of the link N2 to N3 is reduces to 2. That means the 6 is reduced to 2. Then what will be the new distance vector at node N3? That is the question. So in N3 node it is N3 to N1. Actually this was 1 plus 6, 7. Okay, 7. But now the 6 is changed to 2, so that it will become as 3. Okay, then N3 to N2, it was 6, but now it is 2. Okay, then N3 through N3 to the same node itself is 0. Then N3 to N4, no change, it is 2. N3 to N5, it is, if we go by this way, it is 4 plus 2, 6. If we go by this way, it is 3 plus 2, 5. So now this is changed as 5. So after the update of this link, N1 to N2 to N3 from 6 to 2, this will be the modification. So option A will be the answer. The next question, after the update in the previous question, the link N1 to N2 goes down. So then N2 will reflect this change immediately in its distance vector as cost infinity. After the next round of update, what will be the cost N1 in the distance vector of N3? So in the previous question, we will get N3, then this is N1, N2, N3, N4, N5. So to N3 to N1, this is changed to 2. So 1 plus 2, 3, N1 to N2, 2, N3 to N3, 0, N3 to N4, 2, N3 to N5, it was 5. This was the cost. Now what has happened? This is breakdown. Okay. And now what is the change in N3? That is a question. So whenever this breakdown happens, immediately this N2 will change its value to N2 to N1 will to 0. So first of all, we need what is the cost of N2 to N1? It was 1, N2 to N2 0, N2 to N3 it is 2, N2 to N4 2 plus 2 4, 3 plus 4 7. So 2 plus 2 4, N2 to N5 it is 3. This was the cost. Now the link between N2 and N1 is breakdown, so that this one will be changed to infinity. What is the change of these values now? This is the question. So regarding N3, N3 is going to receive the tables of N2 and N4 in order to update the table of N3. So now N3 has the table of N2 and N4. N4 table is also there. What is N4 to N1? Previously it was 2 plus 2, 4 plus 5. If we go by this way, 4 plus 3 plus 1, 8. So 5 will be the shortest answer. So N4 to N1 was 5. N4 to N2, 2 plus 2, 4. N4 to N3 it is 2. N4 to N4 0. N4 to N5 it is 4. So this was the table. So this is N3 will receive the table of N2 and N4 here. Whenever N3 receives N2, this value is changed to infinity, so that the cost from N3 to N1, N3 to N1, 3 plus infinity will become infinity. So this is not a shortest distance. Then it will go to the N4 table, change with the N4 table. So if N3 tries to reach to N1 bar through N4, what will be the cost? 2 plus 4, 6 plus 3 plus 1, 10. Because this 1 is not updated in the table of N4. So 10 will be the answer. Thank you. See you in another video.